At the end of the last video, I introduced you to the transform method on string. In this challenge, I want you to explore what you can do with that method. First, create an array of names in mixed case, as you did in the Lambda expression challenge. Create a list of function interfaces, or alternately, unary operator, which will contain all the operations you want executed on each name in your array. Do something similar to what we did in the Lambda expression challenge. Make each name uppercase, add a random middle initial, add a last name which should be the reverse of the first. In addition to this, add some custom transformations of your own. Use a mix of Lambda expressions and method references. Create a method that takes the name array and the function list and applies each function to each name using the transform method on string to do this. All changes should be applied to the original array. Make sure you explore as many transformations as you can, trying as many different types of method references as you can think of. Really try to have some fun and be creative with this challenge. If you come up with something really neat, make sure you post it in the Q&A section. Okay, so it's time for you to attempt this. Give it a go now, and when you're done, come back and see if you came up with similar approaches to my code. Pause the video now. Okay, so how'd it go? Did you have some surprises? Did you explore a variety of method references? Let's see what I've come up with. I'm starting with a new project called Method Reference Challenge. I'm going to add a private static random field to support different types of randomization, assigning it a new instance of the random class. Next, I want to set up the method that will execute my list of functions against an array of names. This will be a private static method called applyChanges that has a void return type. The first parameter will be a string array, and the second will be a list of typed unary operators of type string called string functions. This list will consist of instances which implement the unary operator interface and accept strings. I said in the last video that the transform method will return other values, but here I'm going to use it with just strings being returned. Using a unary operator is basically the same as using a function with strings as both type arguments. Now I'll add the main parts of this method. Let me type this out and then I'll explain it. Time to unpack this a little. First, I create a list backed by an array, my names array. Then I'm looping through the list of functions which were passed as the second argument of this method. These are the operations that will be performed on each name in the array. I'm taking advantage of the replace all method on list here, which takes a unary operator, and I pass this a lambda expression. This lambda in turn calls transform on every string and executes the function that was in the list element. After this, I print out the array values. Note that I am printing the array values after each transform and not just at the end. Because I'm using a list backed by an array, the array is really changing during these transformations. Okay, so I want to test this out, but first I need some names in an array. I'll call my local variable names and use an array initializer with Anna, Bob, Cameron, Donald, Eva and Francis as my names. Now I need a list of functions. I'll set this up. So list and set the type argument to unary operator, which also needs a type argument, and that's string. So this declaration will look a little ugly. I'll call my list and assign it a new array list, passing a call to the list.of method. I'll leave some space for my first method reference or lambda expression. I want to first make the names all uppercase, as I did in the lambda expression challenge. So what does this look like as a method reference? Do you remember? Let me add that here. String : 2 uppercase. This may look like a static method reference, but hopefully you recognize that it's not. It's an instance method used on the unbounded retriever. In other words, the method will get called on the first argument, and now all I have to do is call my applyChanges method, passing the names array and the list of functions. I'll run this and see what I get. As you can see, my names have been transformed to uppercase with that method reference call. My first operation works successfully on the names array. Next, I want to add a random character as a middle initial. I'm going to create a method similar to the one I used in the Lambda expression challenge, calling it getRandomChar. This is almost the same method from the previous challenge. It uses a range of characters specified by the user to get a new random character. And now I'll add a lambda expression to my list in the main method that uses this method. I'll need a comma after the first method reference, then I'll add a method reference. This should look familiar because I used almost the exact same one in the Lambda expression challenge. So S plus equals a space plus a call to get random char. But this time I want a middle initial between D and M, and I'll append a period to that initial. And running that code now, I get a random letter between D and M for all of my names. The selection of this letter range is just arbitrary. The third thing I did in the Lambda expression challenge was to take the first name and reverse the letters and add that as the last name. How should we do that here? Well, I'm going to create two overloaded methods, both private and static, both named reverse and both returning a string. The first takes a string, as well as a starting index and an ending index. It will return a new string builder, which gets past the substring derived by the starting and ending indices. The reverse method is chained to that, and then the toString method. The overloaded version will reverse the entire string, so it only has a single string parameter, and it in turn calls the other version, passing 0 and the length of the string as arguments to that. I'll now add a method reference in my list in the main method, after adding a comma after the previous expression, and I'm simply going to call main : reverse. This will reverse the entire string, which isn't quite what I want to do, but I did want to talk about this kind of method reference. What do you think? What kind of method reference is this specifically? Well, this one is really a static method reference, and the string is passed as the argument to the reverse method. Running the code with this extra function now, you can see the entire name was reversed. Since that's not what I want, I'll actually insert a Lambda expression before that last method reference. This will execute S plus equals empty space, then a call to the reverse method passing 0 as the start index and the index of the first space. This means I'm really passing just the first name to this reverse method, and that will get reversed and concatenated to the current name, running this code. You can now see on the third line of output the effect of this method, which again did the same thing we did in the Lambda expression challenge. Notice the last piece of output, the fully reversed name, looks almost the same as unreversed, only the period and middle initial is swapped. Okay, so I've included 2 of the 4 types of method references. Is there a way to use the other 2? What happens if I had a string constructor method reference? I'll add a comma after the main : reverse, and then use a method reference for a new string. This compiles, but how does that work? Let me add the corresponding Lambda expression directly below it. I need to add a comma after the last expression first, then I'll add S arrow, a new string passing S to that constructor. Both of these return a new string, which is constructed using the current text value. I'll run this code now. You can't really see anything changed, since the code is really setting each name to a new string instance, passing it its own text value. Instead of new, I can use value of with the same results. I can achieve this by adding another comma after the last expression, then string : value of. The results in all of these becoming new string instances, but with text values the same as before. These aren't particularly useful, though I have more flexibility with the Lambda expression. I could, for example, add something to the name as I create a new string. Let's see what that produces. You can see that the last 2 outputs have the text howdy prefixed now. Notice that IntelliJ isn't really happy with me using new string. Instead, it wants me to just use the string literal added to S. I'm not going to make that change. I included this line to help you understand what the 2 methods string : new and string : value of look like as a Lambda expression using constructor code. So I'll just comment this line out. Okay, for the last method reference type, I'll set up a private person record in my main class with one field, a string name first. I want to add a public method to this record called last that takes a string. It returns the first field with a space concatenated to it. This is followed by a substring of the argument passed, which represents the first string in a space delimited string. I'll set up a person in the main method and pass Tim as the name. Now I can demonstrate the 4th type of method reference, an instance method called on an instance using a bounded receiver. This means the instance is coming from code external to the reference itself. Running that code now. You can see my name with the first part of all the other names. This was the result of executing last on the Tim record, but passing each name to the last method on the Tim instance. When you're using an instance, you can use an expression on the left side of the method reference. Let me add an example of that. And that gives me records with Mary as the first name and Tim as the last name. Okay, I hope you had a lot of fun with this challenge. There's really no end to the number and type of method references and lambda expressions you could add here. But would you ever code something this way? Probably not, but I hope it was fun for you and you got creative with it. If you want to execute a lot of functionality in a sort of ordered task list way, like this, you'd probably do it using functional interface method chaining, or with streams. In the next video, I'll be talking about functional interface method chaining, so I'll see you in that next video.